Okay, example 5 is another way they can give you a problem involving this theorem. A triangle has sides measuring 11 and 16. They want the possible lengths of the third side of the triangle. All right, so what I'm looking at here is some triangle. I don't know, I'm going to just draw it just so you can look at what it looks like. But let's say this is 11 and this is 16, and the third side, let's say, is x. Okay, not drawing to scale, I didn't measure anything, I'm just drawing a generic triangle here. Okay, since I don't know what the third side is, it wants all the possible lengths. I want to write all three inequalities for this set of sides. So the three sides are x, 11, and 16. According to the triangle inequality theorem, all three of these have to be true at the same time. X plus 11 has to be bigger than 16. X plus 16 has to be bigger than 11. And 16 plus 11 has to be bigger than x. Okay, so you write down all three inequalities. And we're going to solve these for x in order to create a compound inequality to describe the range x can be. Right. Basically, we're going to find x can be bigger than this number, smaller than that number, so it's going to be between two numbers. That's what's going to end up happening here. If I solve each of these individually, the first one, if x plus 11 is greater than 16, I'm simply going to move the 11 over. That gives me x is greater than 5. Okay. Which there are numbers greater than 5, right? So x would be 6 or 7 or so on, right? If I take a look at the second one, if I move the 16 over, minus 16, that gets me x is greater than negative 5. Now, x is representing the side of a triangle, right?
Okay.
So we can agree that x has to be a positive number. If x is a positive number, can we agree no matter what x is, it's going to be bigger than negative 5? So this one right here, although it's true, is basically irrelevant, so I'm going to just strike that one out. Irrelevant doesn't have to help me at all. Okay, you still want to solve everything, but usually you get two relevant and one irrelevant. It's easy enough just to solve it, find the irrelevant, and throw it out. The final one, 16 plus 11, x is already by itself, so this is 27 is greater than x. Now, with inequalities, I like x's on the left. I don't know if you guys are the same as me, but I like them on the left and numbers on the right. So if I want x on the left and 27 on the right, I just need to make sure the inequality is oriented the same way to the two objects. It's opening to 27, it's pointing at x, so I want to make sure it's opening to 27 and pointing at x. All right? So x is greater than 5 and x is less than 27, which means x is between 5 and 27. And inequalities, that's how you write it. 5 is less than x is less than 27. There is no equals to. If it equals, you're looking at a line segment instead of a triangle. It's got to be slightly bigger than 5, slightly less than 27, or anything in between in order to create a triangle. All right? So that's the technique for that, and that's what I expect to see on your paper. Write all three inequalities, solve all three inequalities, give me a good compound inequality answer. Smallest number less than x, less than the biggest number is what it ends up being when you write that final answer. But again, x is bigger than 5, x is bigger than 5, x is less than 27, x is less than 27. It's the same for both things.